Okay, we made it to the last essential question in this unit. How do I write and solve multiplication and division equations? So first, I want you to go back to, that whole idea of balancing the scale, because an equation has both sides being equal, and if that's like a scale, both sides are balanced. So think about this equation. What if I have three x's, 1, 2, 3 x's on the left side, and then I have 9 on the right side. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm going to have to move these over a little bit, give them more space. There we go. Okay, so there's our 3 x's, and that's equal to 9 on the other side of our balance, or on our scale. If you remember, when we talked about addition and subtraction equations, we used the inverse operation, the opposite operation. This time, we have a multiplication equation. This is 3 times x. So think about it. What would be the inverse of multiplication? The inverse of multiplication would be division, which means in order to get this 3 by itself, this x by itself, I'm going to have to divide by 3. I'm going to have to take both sides of my scale and divide it by 3. Obviously, 3 x's divided by 3 is going to give me 1x. And on this side, if I divide this into 3, here's 1 3, here's 2 3's, here's that 3. I'm going to end up with 3. So if I break it up into groups of 3, I have 3 in each group. So the related equation is x is equal to 9 divided by 3. Each of these x's is worth 3 because 3 plus 3 plus 3 gives you 9. You have 9 on the left side, and of course you have 3 3's on the right side, so there's your other 9. So in order to solve a multiplication equation, you have to divide by, in this case, the coefficient, the number that was multiplying the variable. Let's try and do some more equations. Look at workbook page 233. Number 1, we have another multiplication equation. We have 2 x's is equal to 18. If I want to get this x by itself, I'm going to have to divide by 2. That means I now have the related equation of 18 divided by 2. X is equal to 18 divided by 2. And now x must be equal to 9. How about number 2? Sorry, my 9 looks awful. Number 2, x divided by 5 equals 5. Well, now we have a division equation. If I want to get x all by itself, I'm going to have to get rid of that division of 5. And the opposite would be to multiply by 5. Now my related equation is x equals 5 times 5. And that's going to give me 25. And of course you can substitute these back in to make sure they work. Does 2 times 9 equal 18? Yeah, you would get 18 on the left side and 18 on the right. Does 25 divided by 5 give you 5? Yes, because 25 divided by 5 gives you 5 on the left, and of course you already have 5 on the right. Let's take a look at the next one. X divided by 3 equals 9. We have a division equation again, which means I'm going to multiply by 3 in order to get my x by itself. X is going to be equal to 9 times 3. That's the related equation. And that means x must be equal to 27. And we can check it. We can plug it back in using the substitution step. 27 divided by 3, yep, that gives you 9. 9 is equal to 9. Let's write and solve the equation that each model represents with these algebra tiles here. Here I see 4x equals 2, 4, 6, 8. I have 4 x's equals 8. If I want to get the x by itself, I'm going to have to do the opposite or the inverse of the multiplication that's going on. I'm going to divide by my 4. So my related equation is x equals 8 divided by 4. And of course, x is equal to 2. And that works out because 2 plus 2 plus 2 plus 2, you have 4 2's here, there's 8, and of course you already have 8 on the other side. Here I have 3x's equals, let's see, 3, 6, 9, 12. Again, if I want to get my x by itself, I'm going to have to divide by 3, and that means I have to do 12 divided by 3 in my related equation. X is equal to 12 divided by 3, and that tells us that x is worth 4. And we can check it. We can plug it back in. I'm going to take that 4 and plug it in where all my x's are. I have 4 plus 4 plus 4, or 3 4s, which is 12. And of course on the right side I have 12. Done. Now for 11 and 12 on page 233, we're going to make our own algebra tile model and solve the equation. And again, check your work using substitution. I know it seems silly when the equations are pretty small and simple, but eventually you're going to be doing 2- and 3-step, even 4-step equations as you get older, and it helps when you're able to go back and substitute to make sure that you did all of those steps right. Here we have 2x equals 10. So I need 2 x's, and then I need 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 x's is equal to 10. So I'm going to divide by 2 in order to get the x's by them, or the x by themselves. So if I divide this by 2, I get x. And if I divide this side by 2, 1, 2, 3, 5, I'm going to get 5. X is equal to 5. And if I plug it back in to check, I'll use a different color here. So you can see my substitution step. 2 times 5 equals 10. And yes, that works because 2 times 5 is 10, and of course we already have 10 on the right side. Take a look at the next one. We have 4x equals 16. So 4x equals 16, that's my original equation. So 1, 2, 3, 4 x's equals 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I'm going to divide by 4 in order to get my x by itself. So my related equation is x is equal to 16 divided by 4. So if I divide this side by 4, I'm going to get 1x, and if I divide this side by 4, I'm going to have 4 again. X is equal to 4. Now we can substitute it back in to make sure that we did this right. 4 times 4, let's see, that gives me 16 on the left, and of course I have 16 on the right. That works out. X must be equal to 4 because 16 is equal to 16. Alright, now we're going to have a little bit of fun. We're going to talk about the multiplicative inverse. The multiplicative inverse of another number, or a number is the multiplicative inverse of another number if the product of the numbers is 1. Meaning we're trying to find one number that when we multiply it by another number, we get the product or the answer of 1. So I want you to think about reciprocals. Remember reciprocals? The multiplicative inverse of a number is the same as the reciprocal of the number. So let's start with 9. What's the reciprocal of 9? 1 over 9, right? Because right now this is 9 over 1. If we were to flip it, we'd have 1/9. So the multiplicative inverse of 9 would be 1/9. Because watch what happens when you multiply them. 9 times 1 is 9. 1 times 9 is 9. And of course 9/9 is worth 1. That's your multiplicative inverse, 1/9. Because when you multiply it by 9, you get the product of 1. How about 3/4? Well, that's pretty simple. The reciprocal of 3/4 would be 4/3. Just flip it around. And we can check it. 3/4 times 4/3. 3 times 4 is going to give me 12. 4 times 3 is going to give me 12. And that gives me a product of 1. So 4/3 is the multiplicative inverse of 3/4 because when I multiply them together, I get 1. Now you're probably thinking, why do we need to know multiplicative inverse? I'm going to show you. If you look at page 234, solving equations involves isolating the variable, which we've talked about before, trying to get the variable by itself. In some equations, the coefficient of the variable is a fraction. Remember we said the coefficient is the number that multiplies the variable? Well, what if your coefficient is a fraction? One way to solve such an equation is to multiply both sides of the equation by the multiplicative inverse of the coefficient. So let me show you what I'm talking about here. We have 2/3 times x equals 10. You know that we want to get this x by itself. It's a multiplication equation, which means the inverse would be to divide. So basically, we have to divide by 2/3. Here's the thing. How do we divide with fractions? If you remember, we never really did the division. We actually multiplied the reciprocal. That's what we're doing here. Instead of dividing by 2/3, I'm really just multiplying both sides by 3/2. Because remember, whatever we do to one side, we have to do to the other. Over here, 3/2 times 2/3, you have the multiplicative inverse there. You know your product is 1. So you basically have 1 times x on the left side, which anything times 1 is itself, right? 1 times 5 is 5, 1 times 6 is 6, 1 times 100 is 100. 1 times x, well, it's x. And on this side, on the right side of the equal sign, we have 30/2, which is going to give you 15. X must be equal to 15. Let's try another one. Let's look at number 20. We have 1/5 times x equals 4. Again, we want to get x by itself. Well, it's a multiplication equation, meaning I'm going to have to do the inverse operation. The inverse of multiplication is division. However, instead of dividing by 1/5 on both sides, we're really just going to multiply by the reciprocal, because we never really divided with fractions, we only multiplied the reciprocal. Now, in this case, the reciprocal of 1/5 is 5/1, or even just 5 if you want to leave it that way. You don't have to put the 1 underneath. In this case, 5/1 times 1/5, that's going to give you 1. And 1 times x is, of course, x. So when you multiplied by the reciprocal, you got the multiplicative inverse of 1/5. And of course, their product is 1, and 1 times x is x. And on the right side, 4 times 5 is going to give you 20. So x is equal to 20. I know it seems like a lot, but basically you're just multiplying by the reciprocal on both sides. All right, now let's write and solve some multiplication and division equations. Number 28, this is on page 235. 276 people are seated in 12 identical rows for a performance of a school play. Well, how many people are in each row? Let P be the number of people in each row. So in my head, I'm thinking 12 times, 12 times the number of people in each row is equal to 276 total people. Or maybe in your head, maybe you were thinking of the related equation. If you want to figure out the number of people in each row, you must take your 276 people and divide it up into the 12 rows, and that'll tell you how many people are in each row. So in this case, I would have to do 276 divided by 12. And that means I'm going to end up getting 23, I'm going to use a different color here, 23 people in each row. How about number 29? A $20 t-shirt is on sale for 1/10 off, or 1/10 is basically, 10% off. How much money will Sierra save if she buys the shirt on sale? And D is going to be the number of dollars saved. So I don't know if you're aware of this, but if you want to figure out a percent off or a fraction off, it means you actually have to multiply. Some people think, because it's coming off that you have to subtract. But in this case, you have to do some multiplication first. I know that we've got a $20 t-shirt. Let's see, I'm going to use red again. I've got a $20 t-shirt, and I'm going to times it by the 1/10 off, and that's going to help me figure out how much money she is saving. So I'm going to use D for the number of dollars saved. So we have to do 20 times 1/10 to get the number of dollars saved. So 20 over 1 times 1/10 is going to give me 20 over 10, which is 2. So D is going to be $2 saved. She is saving $2, which really means the sale price would be $18, right? If she's saving $2, she's not spending that $2, and the original price was $20, I know that she must be spending $18. Okay, the takeaways. First, remember the multiplicative inverse. You're going to see that again. The multiplicative inverse is also known as the reciprocal of a number, and the product of a number and its multiplicative inverse is always going to be 1. When your coefficient is a fraction, you must multiply by the multiplicative inverse to isolate the variable. And last, remember, when you're solving multiplication and division equations, identify what number you need to eliminate to isolate the variable, and then perform that inverse operation. And of course, go back to the original equation. You can substitute the answer in for the variable to check to make sure that what you're doing is correct.